This is a video for MEI Core Pure Mathematics, Vectors 3, Equations of Lines, 3.5, the intersection of lines in 3 dimensions. The intersection of two lines in 3D gives rise to 4 possibilities. Either they intersect at one point, they're parallel and don't intersect, or they're parallel and collinear. And all of these are the same as within 2D. But in 3D there is an additional possibility. They could be skew lines. And skew lines are not parallel, but don't intersect. And if you look at this picture here, the road at the bottom, the motorway down here, is not parallel to the road that's crossing it on this bridge. But traffic travelling along the motorway will not hit traffic on the bridge because the two lines do not intersect. And that's what we mean by skew lines. Let's start out with an initial example. So for what value of A are these two lines parallel? Well, if I look at the direction vector for this line, it's going to be A, 1, 2. And if I look at the direction vector for this line, it's going to be 1, minus 3, minus 6. For those to be parallel, I want D1 to be a multiple of D2, or vice versa. I want them to be multiples of each other. Well, 1 minus 3 minus 6 looks like that is minus 3 times that. So that would give me that A would need to be minus a third. And if we try that in there, minus a third, 1, 2. If I multiply that by minus 3, I get 1 minus 3 minus 6 as required. So they're parallel when A is minus a third. This next example, we want to find the point of intersection of these two lines. If I write these as column vectors, just to make it easier to see what's happening, so I've got 2, 4, 3 plus lambda times 1, 0, 4. And from this one I've got r is equal to minus 1, 2, 1 plus mu lots of 1, 1, minus 1. And now if I extract the components of each of these, I'll get 2 plus lambda is equal to minus 1 plus mu. I'll get 4 is equal to 2 plus mu. And I'll get 3 plus 4 lambda is equal to 1 minus mu. Let's give these equations numbers so we can play with them, 2 and 3. And my technique is to take the first two equations, 1 and 2, and see if I can solve those for lambda. Well, in fact, straight away from equation 2, I get that mu is equal to 2. And if I plug that in up here in equation 1, I'm going to get that 2 plus lambda is equal to 1, and therefore lambda equals minus 1. And so now we check those values in 3 to see if it's consistent. So in 3, let's have a look at the left-hand side. We get 3 plus 4 lots of minus 1, and that's equal to minus 1. And from the right-hand side, we get 1 minus 2, which is also equal to minus 1. So these two things are equal, which means these equations are consistent. So they do intersect, and they intersect when either mu equals 2 or lambda equals -1, doesn't matter which of these two equations we take, I'm going to use the lambda equals -1 bit of that, so they intersect at 2, 4, 3 plus -1 lots of 1, 0, 4. And that gives me 2 take away 1 is 1, 4 take away nothing is 4, 3 take away 4 is -1. So they intersect at the point 1, 4, -1. There's that written up neatly for you. The first thing is I've pulled out equations for the components for the coordinates. So this is the x, y, and z components. We solve those to get this from the first two equations, and then we check that in 3, and it turns out that we get the same result for both sides, so they are consistent. If there was no solution to this, in other words, if we got different answers for the left-hand side and right-hand side, they would be inconsistent, and therefore there would be no point of intersection. And we then use one of those values, and actually I've used lambda equals -1 in the first equation. I could have used mu equals 2 in the second equation to get the point of intersection 1, 4, -1. Okay, so in this example, we want to determine whether or not these lines intersect. And this is a slightly different question. So the starting point is, have we got parallel lines? Because that would give me a hint as to whether I've got an intersection or not. So are they parallel? Well, my direction vector for the first one is -2, 0, 1. And for the second one is 4, -2, 5. And they are obviously not parallel. They're obviously not parallel because there isn't anything I can multiply this 0 in the middle by to get a -2, so they are not multiples. The next thing to do is to extract equations for the components. So from the first equation, first component, I'm going to get 5 minus 2 lambda is equal to 1 plus 4 mu. From the second one, I'm going to get 12 is equal to 2 minus 2 mu. And from the third one, I'm going to get 2 plus lambda is equal to minus 3 plus 5 mu. And again, let's give those some numbers so we can identify them. Let's call those 1, 2, and 3. So this is the starting point. I'm now going to go on and use a pair of these equations to get values for lambda and mu, and then check that out in the third equation. So there's the halfway house written up for you, extracting firstly the directions from these two things. They're obviously not parallel, and we've seen that. And then this is the equations for the components, and you'll see they agree with what I had on the last slide. So pushing on with that then, we said we would use the first two equations here. And if I use the first two equations, this equation here is going to give me that 2 mu is equal to minus 10. And therefore mu equals minus 5. And if I plug that into here, I get that 5 minus 2 lambda is equal to 1 minus 20. And that gives me lambda is equal to 12. Now I check that out in the third equation. So we're going to check in 3. And to do that, I'm going to look at the left-hand side, which is 2 plus lambda, so that's 2 plus 12 is 14. And the right-hand side, which is minus 3 plus 5 lots of mu, so that's 5 lots of minus 5. And this gives me minus 28. And these two are not the same, so they are inconsistent. So there is no solution. And in fact, we can say furthermore, the lines are skew. They're skew because they're not parallel, but there is no point of intersection. If they had been parallel and no point of intersection, that's exactly what they would have been, parallel. And if they've been parallel with a point of intersection, we'd actually have got a consistent result here and would have ended up with two lines that were exactly the same. And again, there's that written up just a bit more tidily. You solve the first two equations to come out with these values for mu and lambda, and then when you plug them in to do the check values, you find that 14 is not equal to minus 28. So they're inconsistent and therefore are skew. So whether it's in 2 dimensions or 3 dimensions, checking whether or not the lines are parallel is a useful thing to do. However, if they're not parallel, you can still have in 3 dimensions lines which don't intersect because they're skew lines. That was the final video in the sequence Vectors 3 Equations of Lines.